So, you clicked on this video because you want to learn how quantum computers work. Well, I'm going to explain it.
Yeah, buddy!
Chances are high you don't own a quantum computer. That's exactly the reason why I bought one. Okay, nah, I'm just kidding, I don't have one. But how do they work? Well, computers work with bits, right? So they can have the binary state of 0 and 1. Quantum computers work with qubits, so they can have a state of 0 and 1. But they are a little bit more complicated. See, normal bits in a computer work with electricity. If the voltage is high enough, it will send a signal for the 1, if not, for the 0. But it also has a gray area where if the voltage falls into that place, it won't do anything because it's not sure whether it's a 0 or a 1. This is just to prevent false signals. But qubits aren't really powered by electricity. First of all, qubits need to be a physical thing. One such thing could be an atomic nucleus, an electron, proton, or even a photon. You know, the things the sun shoots at us. For our example, let's just take our boy, the atomic nucleus. Since the nucleus is in a magnetic field, its spin, or the direction of its magnetic moment, can point in different directions, commonly up or down with respect to the magnetic field. Another way is to strip an electron off an atom and turn it into an ion. Electromagnetic fields are then used to suspend the ion in free space. To change its state, Bro gets shot with lasers. Another example to create a superposition is to use a current in a loop of superconducting metal. So basically, in a nutshell, it's as if you were running forwards and backwards at the same time. Don't worry if this doesn't make sense to you, I am feeling the same. Moving on, to actually create a superposition, you have to do something to a qubit so that it kinda ends up balanced between states, as if you were trying to balance a small object like a coin. To actually balance it between the states, you could use a magnetic or electric field on it. This leaves us with an equal probability of spinning one way or the other. Why is this so complicated? Good. Now we kinda know what qubits are and what a superposition is. But now we come to the important question. How do you read shit from those qubits? Okay, you have a quantum computer with, say, 64 qubits running and you want to do things with it. All 64 qubits are now in the superposition. Basically like 64 coins that we talked about earlier, all balanced on edge. They all hold 264 possible suspended states. One of these states represents the right answer. However, you have no idea which one because there are just way too many possibilities. Well, you can just read it out, right? Well, no. No, you can't, because those suckers collapse when you read them. This kinda sucks, because you still don't know the answer now. This is as if you were slapping the table with your fist. All the balanced coins would now collapse. So what now? Well, you use a quantum algorithm called Shor's. What it does is it loads the qubits to make them more likely to fall on the correct side and give us the right answer. Okay, so this was all really complicated science, and quantum computers, as they are, probably won't be available to people anytime soon. Currently, quantum computers also suck. Your old laptop from your grandma is probably better than them, because quantum computers only really work with really complex problems that a normal PC would take ages to solve. With normal computations, it will probably be even slower. So yeah, that is the end of the video. Please let me know if you want to see more of this kind of content. So yeah, that's it.